Hello everyone, in this session I will be discussing the Florida International University pedestrian bridge collapse. This tragic event is not only a case study in structural failure, but also a powerful lesson in engineering safety and ethics. The pedestrian bridge was designed to improve safety for FIU students and the community by crossing over Southwest 8th Street in Miami. The project cost about $14 million and was constructed using accelerated bridge construction or ABC. This technique is meant to reduce disruption to traffic by assembling large sections offsite and moving them into place quickly. Construction began in 2016. On March 10, 2018, the main span was installed across the road. Just 5 days later, on March 15, 2018, the bridge collapsed, causing catastrophic consequences. On March 15, during the middle of the day, the newly installed span suddenly failed and came crashing down onto a busy traffic. Vehicles were crushed beneath the weight of the concrete structure. Sadly, 6 lives were lost and more than 10 people were injured. This was not just a structural failure, it was a human tragedy. The collapse was traced back to a critical design error at the diagonal truss to deck connection known as Node 1112. This was the joint where a diagonal member met the deck near a vertical support. The design underestimated the loads at this connection, leaving it structurally deficient. Significant cracks had already formed in this area and were clearly visible in the days before the collapse. Yet, they were not treated as signs of imminent danger. Adding to the problem, no temporary shoring was used to support the structure during this critical stage of construction. When Node 1112 failed, the entire truss system lost stability and the bridge came crashing down. This shows how a single weak connection can trigger the failure of an entire structure. The National Transportation Safety Board conducted a thorough investigation in 2019. They concluded that bridge engineers had miscalculated the design capacity. The peer review process failed to catch these errors. The contractor did not stop work, even though major cracks were visible. And finally, oversight from FIU and the Florida Department of Transportation was inadequate. This was a systematic failure across multiple levels. Beyond the technical errors, several other factors contributed. There was intense pressure to meet deadlines under the ABC method. Communication among the stakeholders, engineers, contractors, university officials was insufficient. Most critically, the road underneath the bridge was left open to traffic, even while serious construction issues were ongoing. Closing the road could have prevented the loss of life. This case raises deep ethical questions. As engineers, our first obligation is to public safety, not budgets or schedules. When cracks appeared, action should have been taken immediately. Effective communication across teams is essential, and robust, independent peer review must be a cornerstone of the process. Ultimately, this tragedy reminds us of the ethical duty engineers carry. The collapse influenced national discussions on accelerated bridge construction. While ABC has benefits, it also presents risks if not managed carefully. More broadly, this event reinforced the importance of ethics in engineering practice. It also highlighted the need for stronger oversight, peer review, reforms, and safety-first decision-making. In conclusion, the FIU pedestrian bridge collapse was preventable. The key lesson is that safety must always come first. This event is now part of engineering history, not only for the failure itself, but as a constant reminder of the responsibility we bear as engineers to protect the public. Our designs and decisions affect lives. The next case we will look at is the Silver Bridge collapse of 1967 in Point Pleasant, West Virginia. This was a suspension bridge that failed suddenly during rush hour traffic, causing 46 fatalities. The root cause was traced to a single eye-bar link in the chain suspension system.